This video covers Trig P.4 and Pre-Calc 1.3 Part 1 notes. The topic for today is dealing with linear equations. So in order for us to write a linear equation, we need to know a couple of forms that we want to write our equation in. And those two forms are slope form and point slope form. And slope form is y equals mx plus b. Sometimes this is also called y-intercept form because you're given the y-intercept with the b value. Point slope form is y minus y sub 1 equals m times x minus x sub 1. And the x sub 1 and the y sub 1 in this equation here is the a point on the line, and the m in both of the equations is the slope. So we also need to know a formula to be able to find the slope, and that is where you subtract the two y values and subtract the two x values. Now sometimes you'll see it written as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It doesn't matter as long as you're subtracting them in the same order. So it doesn't matter whether y sub 1 or y sub 2 comes first. What is important though is that the y values are in the numerator, and that tends to be a common mistake because when we're given a coordinate point like here, x comes first and then y. So we tend to put the wrong terms in the numerator when we are calculating our slope. So just be careful of that. Okay, so if I'm going to graph a equation, the easiest form to graph an equation is when it's in slope-intercept form. And slope-intercept form gives you, just like it says, it gives you the slope and it gives you the y-intercept, the m and the b. And that's what you want to pull out of your equation here to be able to graph it on the coordinate plane. So in other words, you have to solve it for y. So in my problem here, y equals mx plus b, my b is negative 2, and my m is 2, but I'm going to write it as a fraction. Because remember, another way that we can find the slope is to also use rise over run. And I have my rise of 2 and my run of 1 if I write it as a fraction. If I just left it as a 2, I wouldn't have that rise over run. So we're going to come over here, and you always want to plot the b first. And it has to go on the y-axis. So you're going to go down to negative 2 and put a dot. And then from there, because that's my y-intercept, I do a rise of up 2 and a run of 1. Because they're both positive, I went up and right. Do that again, up 2 and over 1. And usually when you get 3 dots, that's enough to stop and you can actually draw your line. But I also want to show you that you could actually go the opposite way. You could actually make these both be negative. You could say that it's negative 2 over negative 1. And so I could go down 2 and left 1, and I would still have those dots in that same line. So it doesn't matter if you choose to go right or up and right or left and down for this one, you're both going to get a positive slope. One thing I like to do when I'm all done is I like to check to make sure if this says that it was a positive slope, that my graph has to be coming off into this direction. And the way that I remember that is I just draw an up arrow. This side is positive, this side is negative. And so that I can use that as a quick reminder to come up with the idea of, did I draw this going in the right way? Because a lot of times we'll have all of this information right here, but I'll maybe go up and left, and my line will be going off in this direction, and that's a negative line. So if you can look at the direction of this side of the arrow, that's what a positive slope should look like, and the direction on this side of the arrow, that's the direction that a negative slope should look like. Alright, let's take a look at the next one. Now instead of graphing it, I'm going to actually write the equation. And so because I'm given 2 points here, typically the easiest form to use when you're given 2 points is point slope form. So that's the form I'm going to use. So I'll just rewrite the generic form of the equation down here. And what I'm going to plug into that is my m, and then also my x sub 1 and my y sub 1. So first thing I need to know is what is m. So now we've got to use the slope formula from over here, take the y values and subtract them, take the x values and subtract them. Make sure the x's are in the denominator when you do this. Okay, so when I do 1 minus negative 2/3, that is going to give me 5/3. When I do 1 minus 6, that's negative 5. When I divide that out, I end up getting my m equal to a negative 1/3. So I know that I'm going to put negative 1/3 in for here. Then what I also have to do is pick one of these points. I'm going to choose to pick the easier one, the one that's not negative or a fraction, and plug it in for x sub 1 and y sub 1. So y minus 1 equals negative 1/3 times x minus 1. And then the last thing you want to do is solve it for y, because you've got some like terms that you can combine. So you need to multiply the 1/3 in, negative 1/3 in, and then add 1 to both sides. And you would end up with y equals negative 1/3 x plus 4/3. And that would be the equation for this line. So again, just to recap again, when you use the formula here, the numbers that you're going to plug in are your x, y values, so the x sub 1 and the y sub 1, and you have to calculate the slope. Alright, the next concept we're going to talk about is the difference between perpendicular and parallel lines. One key characteristic about perpendicular and parallel lines is the idea that their slopes are either the same or negative reciprocals. If they're parallel lines, they're going to have the same slope. That should make sense because we talk about parallel lines, they're going to be running off in the same direction, they're never going to intersect, so they have to be going off on the same slope. If we talk about perpendicular lines, their slopes are negative reciprocals. So it should make sense also if I talk about perpendicular lines. So we have one going that way, one going that way, and they form a right angle. Notice that one slope has to be positive, one slope has to be negative, so that's where we get the negative part. And the reciprocal is that they're just going off in the flipping the fraction around is the definition of reciprocal. So, for example, if I knew that the slope of this line was 2/3, then the slope of this line, if I knew that it was perpendicular, would be negative, and then take the reciprocal of this 3/2. So this is an example of what I mean by negative reciprocals. So if I ask you to define the fact that, or answer the question, are these lines parallel, perpendicular, or neither, all you have to do is find the slope of both of the lines. So if I want to find the slope of line 1, so we'll call it m1, and then I'll find the slope of m2. You're going to take the y values, negative 1 and 5, and subtract. And the x values, negative 2 and 1, and subtract. And when I do that, I get negative 6 over negative 3, and that's actually going to give me a positive 3. On the other hand, over here, when I use the line 2 x, y values, I'm going to do 3 minus negative 5, and 1 minus 5. So that's going to give me 8 and negative 4. And I'm just recognizing I made a mistake here. I did not divide correctly, so let me go back to this. Negative 6 divided by negative 3 is 2, not 3. Over here, I'm going to get negative 2. So the question that I have for you, are these parallel, perpendicular, or neither? Well, they're not parallel because they're not exactly the same. They're not perpendicular because the negative reciprocal of this would have to be, make this a fraction, it would be 2 over 1, flip that fraction upside down and be 1 over 2, and then that would be negative. And this is negative 2, so therefore they're not reciprocals. So we can answer the question then and say that no, these are not perpendicular or parallel, so this would actually be a neither. Be careful because you'll see positive and negative and you'll think right away, oh, these are like I said, you'll think that these are perpendicular, and they're really not. So be careful with that. Next one says to write the slope-intercept form, so that's y equals mx plus b, of the equations of a line that is parallel and perpendicular to this equation here. And it also has to go through this x sub 1, y sub 1 value. So if it's parallel, I know that the slopes have to be the same. And if they're perpendicular, I know that we have to do negative reciprocal slope. So first thing I need to do is solve this equation for y to be able to find the slope. So I'm going to get rid of the x, and that's going to give me 3y equals negative 5x. And so if we keep solving for y, we'd end up dividing by 3, we'd end up getting y equals negative 5/3. My board doesn't want to seem to work. X. So this line here is going to have a slope of negative 5/3. And this slope here is going to have a slope of positive 5/3. So let's use those numbers in our equation now. So what I'm going to do is I'm going to plug into point slope form these two x and y values and my slope of negative 5/3. So y minus 3/4 equals negative 5/3 times x minus 7/8. And then I'm going to have to use the distributive property. And that's going to end up giving me 35 over 24. And then we'll add 3/4. And y would be equal then to negative 5/3 x plus 53 over 24. So make sure you pay attention to the fact that it said it wanted in slope-intercept form, and you give your answer in slope-intercept form. Even though I used point slope form to help me get it, when I was all done, it had to be in slope-intercept form. And then if I look at the next one, I'm going to use the same x and y values, but I'm going to use a slope of 5/3. So y minus 3/4 equals positive, and actually I just noticed that that's not the negative reciprocal, that's just the negative. My slope actually is going to be 3/5. So I'm glad I caught that. So the negative reciprocal is 3/5 not of negative 5/3, not 5/3. So I should be using 3/5 over here times x minus 7/8. X minus 7/8. And so if I use the distributive property, I get 3/5 x and minus 21 over 40, and I'll add 3/4. And I'll end up with y being equal to 3/5 x plus 9 over 40. Alright, our next example says a school district purchases a printer for $25,000, and 10 years later it's going to have to be replaced, and it's expected to be worth $2,000. Write a linear equation giving the value v of the equipment after 10 years. So here's what I know. If I write a coordinate point as years comma value, when I've had the printer for 0 years, the value was $25,000. 10 years later, it drops down to 2,000. So what I can look at now is say that this is my y-intercept, because that's where the x value is 0. So my b is actually really 25,000. All I have to do to be able to write it in this form, my equation for my line, would be to find the m. So if I find the slope, I would take the y values divided by the x values. Oops. And I end up with negative 23,000 over negative 10, and that makes my slope be 2,300. Negative 2,300, because this is actually positive. So now I can write my equation, plug in my b and plug in my m. Y equals negative 2,300 x plus 25,000. And actually they said find the value v, so you'd want to write that as a v.